Hey guys, welcome to my YouTube channel. I'll be solving LeetCode 75 list using Go. So today's problem is reverse vowels of a string. Given a string S, reverse only all the vowels in the string and return it. The vowels are A, E, I, O, U and they can appear in lower and upper cases. That's important, and they can appear more than once. Okay, so for example, if you take this string ice cream, the vowels are I, E, E, and A. So basically, these are the vowels, and you need to reverse them. So instead of I here, I in the first character, it will be replaced by A. C will remain as it is, and instead of E, it will replaced by E because here also it's E, and then C as it is, R as it is, E again it's E, A is nothing but I, and then M. So it's a simple question. Basically, like you collect all the vowels, and the order in which the vowels appear should be reversed while you're returning the string. So we'll basically be returning that, and there is the logic is sort of simple. There is no other edge cases. The only thing is you need to be able to handle both upper and lower case characters, and it usually consists of ASCII characters. So yeah, that's good. Now let's see how I'm going to solve it. As I said, you can, there is multiple ways of solving this. One is just go from left to right, put all the vowels in a stack, and then again traverse it. Every time you see a vowel, you can sort of pop the stack and attach the character associated with that top of the stack into that position. So basically you'll have to convert it into a list and sort of do that. That's one method. But even if you do that, you are basically consuming extra memory as you are sort of appending all the vowels initially to a stack. So let's not do that. What I am thinking is more of a two pointer solution. So have a pointer, one at the beginning, one at the end, and then keep moving them until you find a vowel. So I is a vowel and then A is a vowel. So when both of them are vowel, just swap it, and again just keep moving them till both of them are vowel, and then swap it. So basically it's a two pointer approach where one pointer will be at the beginning, one pointer will be at the end. Keep moving them till they are vowel. Once they both are vowel, swap it. That's the logic. The advantage of doing this is you will be able to get O of n time and O of 1 space, which is like the most efficient way of doing it. And also, that is just the algorithmic efficiency. I'll also be telling you like how to write the most efficient 100% runtime type of code in Go. Since Go is very specific for optimization, I'll tell you how to write highly performance intensive code here. And one more thing, I will explain it to you once I write that. So first, let me define all the stages. So initialization and the core two pointer logic, and probably return after that. Okay. So yeah, so ruins is equal to runes of S. I think it's rune. Yeah, so this is like the most important part. Like if you have seen my other videos, I used to convert strings into bytes, but here I'm converting ruin strings into ruins. Why is that? See, in Go, uh, basically string is represented using bytes. Basically, they are UTF-8 characters. But what happens is, let's say some of the characters, like emoji or something, can take up more than a single byte. So in that case, if you traverse byte one after another, you might not get the correct characters. In this problem, it's fine because we are only dealing with ASCII characters. So ASCII characters, they don't take more than one byte. But in real case scenario, when you're working on Go type projects, you might be dealing with other special characters like emojis and other special characters, in which case it the character size can be more than one byte. So in that case, if you represent string in terms of bytes, then your logic can go wrong. So it's important to practice now itself to converting them into ruin. So ruin is basically converts string into each, it basically represents string as each individual characters. So even if it is a special character or a normal character, it basically gives a character level representation to a string. Assume like a list of characters. So we converted into that, and then let's initialize uh, left comma right. So the left is 0 and right is um, len of s minus 1. Okay, and then we also need a function to check if a certain character is vowel or not. I will show you how to do that as well. For now, let's see the core logic. Sorry, there is no while loop in Go, so that's one of the main changes from your regular languages. So while left is less than right, let's go here, and then again while left is less than right and not is vowel of s of left. So left plus plus, and yeah, you can't do and here, you'll have to do this instead, and I'll implement this vowel later. And again left is less than right, and again is vowel s of right minus minus. So at this point, both left and right are pointing towards a vowel. So swap them. S of left, S of right is equal to S of right, S of left, and then again increment left, decrement right. I don't know why I cannot assign S of left. It should be possible to assign. Oh, sorry, it shouldn't be S. Ruins. Yeah, that's a huge mistake. Never do that. Your string is not mutable in Go, so that would have never worked. And after you do that, you need to return a string, right? So convert your ruins, which is a list of characters, into a string and return it. and we are still not done. We still have to implement is vowel, is underscore vowel. So it takes rune as input and it gives bool as output. So switch C case A I U and again caps A E I O U. So if this is the thing, return true, default return false. I hope the syntax of switch is correct, and I'll also explain you why I wrote it like this. So there are a couple of ways in which you can do the check, and there are ways wherein you can just write it in a single line. But the reason I wrote such an exhaustive thing is because this is the most optimal way you can do it. Because doing it like this, it avoids any function calling, and it directly tries to map it to different characters. So this is like the fastest way you can do it. If you use other built-in methods like string, it does a function call and then that would again incur latency. So if you're dealing with performance critical application, do it like this. So yeah, and that is fine. And then okay, again, sorry, this shouldn't be s. As I mentioned, string is immutable, so we should never use that. Okay, now let me check the code. Ruins, I've declared it. Left and right, left is left less than right, left is less than right, and if it until it's a vowel, keep moving. Left is less than right, and until it's a vowel, keep coming back right. Now it's a vowel, left right, right left, swapped it. Again just increment the pointers, return it as a string because we need to return a string. So yeah. I don't see its runtime seems to be bad. Why is that? Let's recompile. 47%. When left is less than right. Yeah, the logic is correct. So I don't know why the runtime is slow, because this is like the most optimal way of doing it. But maybe let me just run it once more. Doesn't seem to change. But yeah, regardless, still the time and space complexity is very optimal. We can check that we are just using a two-pointer approach. So this will just take off O of n time, and then like we do have a extra space here, ruins, and then we are converting string into ruins, and then we are processing. So I think we are using extra space. Sorry, it's not O of 1 space, it's O of n space. So time is O of n because we are looping it, and then space is also O of n because we are converting it into ruins, and we are declaring a slice here. So yeah, that's it for today, guys. Ideally, like, this was supposed to have a very high performance because of the, sorry, it was supposed to have very high performance because of the function calling and everything that we have avoided here. But the editor is sort of weird, every time it gives different runtimes, but ideally the code here is optimal. So that's it for today, and looking forward to meet you guys in the next video.